Hi everyone, this is Sambit. So I'm going to present you one of the predictive machine learning models that I built for employee promotion project and to help the organization to predict the promotion of efficient employees. So let's see. Okay, so these are the contents that I'm going to discuss. So objectives, dataset review, then workflow, model deployment, and insights and conclusions. So in model deployment part, would be quite exciting because I'm going to deploy our model live on the local server using web framework and get the prediction of our test data of employees that has been given to us to predict, right? So stay tuned, guys. Okay, so what is this project about? So before understanding the project, I have listed down a few benefits of employee promotion for the organization, as you can see on the slides. But the main challenging thing here is like from the organization perspective, when and how to promote the employees, right? So I have analyzed various parameters which affect the promotion of an employee for the organization and developed a machine learning model to predict the employee is really ready for the promotion or not. So let's see. Okay, so this is the dataset that has been given to us to build a machine learning model and predict our target variable. So here I've listed down various predictors. You can see employee ID, department, region, education, gender, etc. Right. So we have to analyze the predictors and predict our target variable, that is promoted variable. So each promoted column basically refers to the promotion of employees. So as you can see, it is a binary classification problem. So 0 is basically represented as the employees who is not getting promoted, and 1 is represented as the employee who is getting promoted, right? Okay, so data pre-processing, this is the basic first step towards building a machine learning model. So in real-time scenario, it takes 50% of time to pre-process the data and make your data ready for the model, right? So it involves few steps, right? Data cleaning, missing value treatment, and outlier treatment. So let's see one by one. So data cleaning. So data cleaning basically means it removes irrelevant or useless column which hardly create any impact to our target variable, that is promotion. So here we have employee ID that you can easily sense that employee ID is hardly creating any impact on promotion, right? So I have dropped this. So let's come into missing value treatment. So before going to treat the missing value, we have to understand the randomness of missing value with respect to target variable. So what I've done, I have created Python function to check the randomness of missing value. So what I mean here is the employee who got promoted, actually those employee has more missing value or vice versa, right? So we have to check the relationship between the NaN values with our target variable. So fortunately, our dataset does our dataset those value which is NaN value doesn't have any relationship with our target variable. So yes, I have found missing values on two columns, that is education and previous year rating. So what I've done, by looking into the education column data distribution, we can sense that the more value won't helpful to treat the missing data here. So I have used KNN classifier, like KNN algorithm I have used to predict the missing data here for the education column. So it would be quite efficient to treat the missing data. Okay, so missing value treatment for previous year rating. So previous year rating has also missing values. By looking into the distribution, you can see the mode value doesn't guarantee the effectiveness of missing value. So I have treated the missing value with more value, but additionally what I have done, I have added a separate column with value 1 to the respective non-treated values and 0 to the not null values in a separate column, which helps the model to give a weightage to the non-treated values, right? So this is the basic ways that I have treated the missing values. Okay, next coming to outlier treatment. So before going to treat your outliers, uh, always have a basic in mind that we have to know the business scenarios, right? So sometimes what happens, the outliers maybe impact your business or your target variable, right? So we have to learn the basics of business scenario. So our H column found to have outliers. like how did I treat the outliers in the edge columns? As you know, edge is normally distributed, so we can eliminate or restrict the edge distribution to three standard deviation methods. So I have used three standard deviation method to treat or replace the outliers. So whichever values that comes after the three standard deviation boundary, I have treated those values or replaced those values with logical values. I can perform IQR, that is interquartile length, but that is more preferable when your variable is skewed. You can perform that. But as edge is normally distributed, I have used three standard deviation method to treat the outliers. Okay, few ordinal variables have like recruitment channel, ads on have the outliers, but these outliers could be valuable for our business, so I have kept it as it is. Okay, so exploratory data analysis. So you can see the distribution of target variable is highly imbalanced, so there is always a chance of our machine learning model getting biased to the minority classes, right? um, so in order to avoid this, we need to perform sampling algorithm. So I have used oversampling here. So there is a note here: always avoid using undersampling, because there is always a risk of less information for our machine learning model to predict the promotion, right? Okay, let's come to univariate and bivariate analysis. So I have attached two box plot for two continuous column, that is edge column and average training score. So as you can see, the second box plot, that is for average training score with is promoted column. The uh, the median value in the IQR range that fluctuates it fluctuates more with the employee got promoted and didn't get promoted, right? So we can say that there is always a correlation with the average training score with the promotion, right? Unlikely in the age column. So we can say that average training score variable is more influential to the target variable than age. Okay. Okay, so one more univariate bivariate analysis. So these I'm discussing about the insight, right? It can be treated as insights for the business side. Okay, so you can see the grouped bar plot that I have plotted here. From the category variable, we can visualize those employees who got KPI metrics greater than 80 has more likely to get promoted. No, you can easily identify by seeing the grouped bar plot for KPI metric and is promoted, right? And second one is previous year rating versus promotion. Okay, so by looking into the plot, you can easily uh, see that the employee who had 3 and 5 as previous year rating were comparatively got promoted the most. You can see the green bar plot, which is from like the employee who got promoted, had the highest numbers in 3 and 5, right? But we can infer and see those who got 4 and 5, the chances of getting promotion is very high, as the ratio of not getting promotion is low as compared to 1 to 3, because you can see in the employee who got 1 to 3, there is always a like big gap between the like getting promotion and not getting promoted, right? There is a big gap. So you can see mm, we can see those who got 4 and 5, the chances of getting promotion is pretty much high than 1 to 3, right? Okay, so one more univariate and bivariate analysis. The employees who did not get awards, the chances of not getting promoted is high as compared to the employees who got awards. So by looking into the grouped bar plot, we can say the employees who own awards, their chances of not getting promoted is quite minimal, or you can say quite negligible, right? Okay, so these are the analysis in visualization side. So let's do the measurement for the strength of the bivariate analysis, what we have seen in the visualization analysis by doing the bar plot. Okay, so to know the strength of the bivariate analysis, we have to perform the hypothesis testing. So I have performed ANOVA testing and chi-square testing. So ANOVA testing is done between the continuous column and categorical column. As you know, the target variable is categorical, so I have performed ANOVA test as well as chi-square test between the categorical and target variable. So all the target all the categorical and continuous column in our dataset have an impact, as the p value, that is the probability value, is less than 0.05 for all the columns. So we can say that is not enough evidence to accept the null hypothesis. So null, like the hypothesis, so the null hypothesis is basically saying the means of predictors and the target variables are same. So there is not there is no such correlation between the predictors and the target variable. So we have to reject our null hypothesis and accept the alternative hypothesis. So our alternative hypothesis is saying there is some correlation between the variable. So after doing ANOVA testing and chi-square testing, I am accepting all the categorical and continuous column in our dataset. So coming to encoding techniques, so there are several categorical variable in our dataset. So for department categorical variable, in department categorical variable there are several unique values. So I have calculated all the unique repetitions of each department value. Then I have calculated the mean and assigned the rank value according to the mean. So for education ordinal categorical column, so I have used ordinal level in encoding that refers to like assigning higher rank to the higher education system. Then coming to region column, so region column actually has a large number of unique values. So I have mapped each number of repetition to each respective region. So yes, for recruitment channel and gender, so both are nominal categorical variables. So I've used one hot encoding. So one note to remember here. So whenever we are performing one hot encoding, we have to drop first as true. Like we have to keep drop first as true. So what it does, so suppose when we take example of gender, so when we are performing one word encoding in gender, so it creates two distinct column using two unique values of gender, that is gender male and gender female. So when you are dropping the first column, so suppose you are dropping gender male, so in gender female column, whenever the model finds 0, so it takes as gender male, and whenever the model gets once one in the gender female column, it considers it as gender female. So by this way, we are going to avoid dummy variable trap. So by avoiding dummy variable trap, we can avoid dimensional complexity. So coming to machine learning model building part. So I have developed ML model using several algorithms like logistic regression, decision tree classifier, random forest, AdaBoost, and XGBoost. So I have chosen hyperparameter tune XGBoost as it is giving higher accuracy and ROC value. So hyperparameter tuning is basically controls the complexity of trees. So I have tuned them all together to get good trade-off bias and variance, that is low bias and low variance. Uh, so I have used various parameters for tuning the model. So let's put some lights on the tuned parameter. Okay, so I've used learning rate, max depth, minimum child weight, gamma, and column samples. So okay, let's go one by one. So learning rate. So learning rate, as you know, in gradient boosting, new trees are being created to correct the residual errors. So learning rate is basically used to stop the model fitting quickly. That is eventually stops the overfitting, right? So coming to max depth, so max depth, as the name suggests, it is basically it allowed the number of node from the root to the leaf of the tree. And gamma value is like it is most important parameter for the XGBoost. So it is a regularization parameter which refers to minimal gain so that another split will happen. So more the number, like more the value of gamma, so more conservative would be the model, right? So yes, then after hyperparameter tuned, I have got F1 score. So I have used grid search CV. So grid search cross validation. By doing that, I have got F1 score as 94%. So F1 score basically refers to the harmonic mean of precision and recall, right? and good ROC AUC value. So highest the ROC score, so better the model distinguishing between the positive and negative classes. So that is true positive and true negative. So basically it refers that we can rely our model pretty much. So yes, so let's okay, this is model deployment part. So I have used basically two methods. One is cron job, one is web service part. So basically cron job, actually I have built a Python function. Mm, so what is the batch job means, like it could be scheduled to run at any particular time to generate the prediction. And for web service part, I have developed Flask web APIs for the prediction. So Flask is basically a web framework for Python, which provides the like some functionalities to build app or manages our HTTP request, that is get or post. So for UI part, as you can see in my screen, like I have attached a screenshot in my slide. So it is a Swagger API. So Swagger API basically uh, it is a great tool for the visualization web service which documents our APIs. So it is nothing but it is in Flaskr module. So Flaskr is basically the Flask extension for open APIs. So at the end of the slide, we are going to watch the live deployment of the test data that has been given to us to predict. Okay, so I have listed down all the feature importance bar plot. Like I've tried with several algorithms, so I found few features are more important to distinguish between the uh, to distinguish or create an impact to the target variable. So we can send the KPI metrics, previous year rating, odds on, and training score. Training score is nothing but average training score are the most important features that contributing on the predict of the promotion. So few insights like we have already seen in the bivariate analysis, and so the organization can give emphasis on these important parameters to take the decisions of promoting or not promoting an employee. And one more insight that I can I would like to give, that is age and gender is hardly contribute to the promotion, right? Okay, so next is model deployment. So we are going to watch the live deployment and gonna give our test data to the model in order to get the response, that is our promotion of employees, right? Okay, let's see. So before going to show you deployment, guys, I want to let you know what are the test data, like what are there in test data which we are giving to our model, right? So the test data contains all the parameters that we were talking about in the whole slide, right? So all these parameters we are going to give our model, and in return we are going to get the response, that is the promotion of employees or the target variable. So let's see. Okay. Okay, before going to up our local server, I am going to show you. So these two endpoints that I have created in Flask. So I want you guys to remember that one is welcome, another one is predict file. Okay, so let's see. Let's up our local server. Okay, so we have got the IP address and the port running in the local server. Let's click it. Okay, so it is showing no URL found, because actually it has upper server, but the thing is that we need to give proper endpoint that we have created in Flask, right? So one is welcome that I've created. Okay, so yes, the endpoint is working fine. So it print the statement that I have given in that particular endpoint function. Okay, next let's go and predict our parameters. So API docs. So we have to write API docs in order to go to Swagger API. So in Swagger API, basically it gives the front end part. So whichever endpoint that you create, it provides a tab format to print all your APIs. So okay, we got our API in the Swagger front end. So we're going to upload, try it out. We're going to upload our test data that I have shown you just before. And it contains all the predictors of all the parameters of employees, right? So in order to um, predict the promotion part. Okay, Okay, so we got all the parameter and responses in a JSON format, right? So we have got all in JSON format. We can do one thing, we can download it. We can download the JSON file and we can go and JSON to convert JSON to CSV in order to give you guys to a visualize representation so that we can understand the responses, right? So let's go, let's downloads. Okay, this is the response that we got. Okay, so that actually it has some 25,000 data, so it will take some time. Okay. Okay guys, so you can see our model has predicted all the uh, target variable, that is promotion, with all the predictors, right? So we have given these predictors to our model to average training score that I have shown you in the data frame. So our model has given a separate predicted status column to give these particular employees are going to get promoted or not, right? So you can see few of employees who got promoted, or many of employees are not going to get promoted, right? So this is the business scenario you can get. Okay guys, this is the whole deployment part that I could show you. Okay, next go to another slide. Okay, so thank you guys. Thank you for listening. Thanks for your attention. Bye bye.